Sorry. All right. Today we are going to make sure that we have a skill needed for the rest of this chapter. Okay, so this is going to be a one-day only thing. Right? We're not going to do a lesson, practice, and graded assignment on this. This is just going to be a lesson and practice today, and then we're going to go on to the next thing tomorrow. Okay, we'll start talking about trig tomorrow. But today, we want to make sure that we can simplify radicals. And so today we're going to look at, first, rationalizing denominators, and then second, simplifying radicals. Okay, so both of these things we need in order to make sure that we can present our answers correctly for the rest of the chapter. All right? So the first thing that we want to take a look at is rationalizing a denominator. Does anybody remember what that means? All right. So rationalizing a denominator, okay, we need to do that whenever we have a square root, or any root, not just a square root, any root in a denominator. Okay, we are not allowed to have roots in a denominator of a fraction. Okay, so in this first example here, our original number was 1 over the square root of 2. We can't have square roots in the denominator. To get rid of square roots in the denominator, what I'm going to do is multiply both the numerator and denominator of that fraction by whatever that square root was. Okay? I'm allowed to do that because something over itself is just equal to 1. I can multiply anything by 1 and it doesn't change the value. Right? So, this is, you had Mr. Haynes, I think you called that a fancy 1. Right? This is just a fancy 1. Right? We're allowed to multiply anything by 1 and that doesn't change its value. So here, what we're going to do is just multiply top and bottom of the fraction by whatever that root in the denominator is. When we do that, remember to multiply fractions, we just multiply straight across. So here, 1 times the square root of 2 is just the square root of 2. The square root of 2 times the square root of 2. I can multiply whatever's on the inside of the radical. So that would give me the square root of 4. Well, what is the square root of 4? 2. Right? The square root of 4 is just 2. So the reason that we do that, okay, multiplying a radical by itself, should always create a perfect square that we can then take the square root of. So I get the square root of 2 over 2. That is my simplified version of my original fraction. And you can put both of these into the calculator. You can say 1 divided by the square root of 2 and get a decimal. Then you can put the square root of 2 over 2 in and get a decimal, and they should be exactly the same. Okay? So, we just need to first get rid of radicals in the denominator of fractions.
The denominator is the bottom.
Right. The denominator is the bottom.
It's D1 on the bottom.
It's D1 on the bottom. There you go. So, for number 2 here, what should I multiply this fraction by?
The 2 is 3. Okay, check it. Square root.
Square root of 3 over the square root of 3.
And the square root of 3 9. That's the square.
You said that backwards. The square root of 9 is 3. So what do I end up with here then?
6 over square root of 3.
So when I've got a number on the outside of a radical and a number on the inside of a radical, I can't just multiply those together. So the 2 would actually stay on the outside of the radical, and then the 3 would stay on the inside. Right? So then what do I get in my denominator here? I would get the square root of 9. What's the square root of 9? 3. Right, so the denominator is just 3. Can I do anything with the numerator? 2 times radical 3? No. make the 2 a square root. It's already on the outside of the root. So that would just stay as is. We getting everything written down back there, paying attention? So 2 radical 3 over 3 would be my final answer. Okay, I got the square root out of the denominator. There's nothing I can cancel. Okay, the second part of the directions say, when possible, simplify by reducing the fraction. Sometimes, and we'll take a look at examples here in a second, okay, we would be able to reduce this after simplifying. Okay, but 2 over 3 cannot be reduced. All right? So that is our final answer. Questions on that? All right, go ahead and try number 3 here.
Really, that'd be like 7 times 7 square root of 7.
Yeah. Blue. Say it.
I tried to do square root of 7 times square root of 7, and I really 2 times 4, 3, 9, 3, 3.
Yeah, yeah. If you think about it like that, it'll be easier. But if you did that in the calculator, it still should turn out square root of 7 times square root of 7.
I think maybe I'll put 2 square roots beside each other.
That could be.
Yeah.
So that would still be the square root. So
Yeah, I just got that.
so you have the square root of 7 over 7. All right, so I got square root of 7 over 7 for number 3. Is that what you guys got? All right, so I just multiplied numerator and denominator by the square root of 7. So 1 times the square root of 7 is just the square root of 7. Square root of 7 times square root of 7 is the square root of 49. And then that is a perfect square. The square root of 49 is just 7. Right? So let's take a look at number 4. Okay, we'll be able to do a little bit more on number 4 to simplify here.
2 square root of 2.
Yep, our first step will be to multiply numerator and denominator by the square root of 2.
And that's going to be like 6 and the square root of 2. Shouldn't it be 4?
Yeah.
I put square root of 2 times square root of 2 and I got 2.
So it will be the square root of 4. What's the square root of 4? 2.
That's dumb.
Okay. So now my next step, I can write this as 6 square root of 2 over 2. Now, here I can actually go one step further. Right? In all of my previous problems, we had 2 over 3, we had 1 over 7. Right? So if I'm looking at the numbers outside of the radical, I can simplify that. I can think about that as just a fraction. So, can I reduce 6 over 2?
Yeah.
How? It's just 3, right? It's just 6 divided by 2 is just 3. So this I can simplify to just 3 times the square root of 2. Now, if you want to write it over 1, you can. Right? You can think about 6 over 2 reduces to 3 over 1. That's okay if you want to write it over 1 like that. Okay, but that's what this last sentence of the directions mean. Okay, whenever possible, reduce the resulting fraction. Okay, be okay with that one? And then try 5 and 6 here. Okay, on both of these, the fraction will reduce. That's good. Thank you. Perfect. What's up? Mikey's being
I'm not going to do it. This is you want your t-shirt now. So it's white.
He posted a shirt with stuff, dude. I love saying that, and that's it's like this was
They like they all sit on it.
all.
Just pretty cool. Well, why should they be just do it that see pictures? Yeah, because you can.
okay.
You're gay. You're gonna be part.
Alright, for number 5, I got 3 times the square root of 5. For number 6, I got 6 times the square root of 7. Alright. Feel okay with those?
Yep.
Alright, so in the next set of problems here, there's something else that's going to happen. Alright, so in addition to getting rid of a radical in a denominator, we also always want to check to see if we can simplify a radical. Okay, we always want to check to see if we can simplify a radical. So sometimes you may be able to recognize one that is easily simplified right off the bat. Right? For example, in number 7, my denominator is the square root of 81. Does anybody recognize anything special about the square root of 81? Right, it's just 9. The square root of 81 is 9. 81 is a perfect square. Right? So, right off the bat here in this problem, I can say that this is just equal to 1 over 9. Right? The square root of 81 is just 9. It's a perfect square. Right? Now, if you wouldn't have recognized that and you would have done the square root of 81 over the square root of 81, okay, you would have gotten to a point where you could simplify. Right? You would have gotten the square root of 81 over 81. Then the square root of 81 is 9. 9 over 81 reduces to 1 over 9. Okay? But recognizing that right off the bat is going to save us a lot of work. Okay? Now, obviously, that's not always the case. We're not always going to have perfect squares here. Okay? Like in the first 6 problems, we didn't have perfect squares like that. We had radicals in our final answer. Here, we don't. This 1 over the square root of 81 is just equal to 1 over 9. I don't have a radical in my denominator anymore. I'm done. So the answer to this one is just 1 over 9. Now, in number 8 here, if I've got 2 over the square root of 11, can I do something like that in this one? No. Right? 11 is not a perfect square. Right? So numbers 8 and 9, we will have to solve similarly to the first set of problems here. Might be. So is 225 a perfect square? There you go. Alright, so this one, just like the one we just did, would be 1 over 15. And we don't have to multiply by the radical because 225 is a perfect square. Right. What about number 12 here? Does something like that happen here? It's quite the pickle. Yeah, I've got this extra number here. Does that look kind of weird?
Wait, could you do like 1 divided by 3?
So, yeah, I mean, we can think about this as 1/3, right? 1 over 3. But then I still have this radical 16 in the denominator.
Wait, can you just do like 1 divided by 3? Okay. It's like the last one, like at the end, you just do like a number, 16, be immediate. But I don't think you do that here.
There we go. Radical 16 is a perfect square.
Sorry, I'm not making.
The square root of 16 is just 4. So this would just become 1 over 3 times 4. And we can replace the radical 16 with a 4. So this is just 1 over 12. Alright. Let's flip over here. I want to jump actually all the way to number 16. Alright, on number 16, okay, we just have 1 over the square root of 12. Is 12 a perfect square? No. Alright, so we can't just say this is going to be equal to 1 over some nice number.
Good. 17. So 121 somehow squared. Squared.
You are correct. Yes, but let's do 16 first. Okay, so I should erase that too. number 16 here. If I've got 1 over the square root of 12, what do you think our first step should be? So yeah, based on what we've been doing, right, multiplying everything by square root of 12 over square root of 12 would probably be a solid first step. So we get square root of 12 over square root of 144, which will just get us 12 in the denominator, right? But on this one, we need to do a little bit more simplifying. Right? It doesn't appear that we would right off the bat.
Just one.
Just what? Just one? No, it's not just going to be 1 because the square root of 12 and 12 are different numbers. So what does that mean?
Stupid.
No. The square root of 12 is like 3.46.
It's not an even number. It's not a perfect square.
12 is not a perfect square. No. So that would mean if I multiply 3.46 times 3.46,
Oh.
I should get
So you just do like
12. Right? Well, no. So when we simplify, we want whole numbers, right? Whether those whole numbers are in the radical or outside of the radical. Right? We should only see whole numbers, right? We shouldn't be seeing decimals. So to simplify this a little bit further, I want to take a look at the square root of 12. Okay? I always want to check to see if that number inside of the radical is divisible by any perfect squares. Right? I always want to check to see if the number inside of the radical is divisible by any perfect squares. So in some of the ones that were perfect squares, right, like 81, that was itself a perfect square. Is 12, so first of all, what are the perfect squares?
like 25, 36.
Let's go a little smaller. See, I mean, you're right, 25 and 36 are.
Right.
So what, we go 1, then, what's the next one? How do we get perfect squares?
I don't know. The number times itself.
Right, so if I do 1 times 1, I get 1,
It's 4.
then 4,
Right?
9,
16, 25.
So whenever I see these numbers, right, and obviously there's a lot more, it keeps going on forever, okay, but these are perfect squares. So like in our one example, we had 1 over the square root of 81. The square root of 81 we know is just 9. But whenever we're simplifying a number, simplifying a radical, we always want to see if a perfect square will divide evenly into that number. Okay, so here, the square root of 12, is 12 divisible by any of these perfect squares? Does 1, 4, 9, 16, do any of those numbers divide evenly into 12?
No. But 4 no. No.
You're thinking backwards. You're thinking, does 12 divide into any of those? I want to know if any of these divide into 12. So that again, that's backwards. So 36 would be divisible by 12. I want to know if 12 is divisible by any of these numbers.
3 times 4 is 4.
Exactly. Okay. So this 12, I can actually split up like this. And I can write this as the square root of 4 times the square root of 3. Okay? know that 12 is just 4 times 3. And obviously this 12 will still stay in the denominator. Now, can I do anything else with this now?
You break both those down? Then
What can I do with the 4?
you make it to 2.
So the square root of 4 I can just make 2. Okay, the square root of 4 is equal to 2. Now, can I do anything else?
I was going to say you could do 12.
Yeah, so this 2 over 12 will reduce. Right, what is 2 over 12 reduce
1
to?
over 6.
It'd be 1 over 6.
1 over 6. Right? Right, so since I still have this square root of 3 in my numerator, I don't have to write the 1. I mean, we could write this as like 1 over 6, and the square root of 3 in the numerator as well. But I don't have to write that 1. Okay, I can just write this as square root of 3 over 6. Alright, so this part is going to be a little bit trickier, right? Whenever we want to try to simplify a radical, right? And we'll work with this a lot more later on, right? The big idea that I want you to get out of today is rationalizing denominators, right? And whenever we have perfect squares, being able to recognize those and simplify those. Okay, this idea we'll work with more later. You are correct. This is a perfect square. So what should I do here?
It should be like 11. It says 11. It was 11, which should be like 1.
There you go. Square root of 121 is just 11. So we get 11 over 11, which is just 1.
And whenever you pop something behind, it's really hard to calculate.
Ah, Jesus.
Okay.
I just noticed it. It's not my whole time. We're all good to know.
Let's see.
All right. So, any questions on simplifying radicals and rationalizing denominators? What I have to follow. That's the lesson for today. All right, so the big thing, we can't have radicals in a denominator. Right? Whenever we see a radical in a denominator, we can check to see if it's a perfect square. Okay, that's possible, right? Which would make our simplifying a lot easier. But if it's not, we would need to multiply both the numerator and denominator by that root, and then try to simplify after that. All right, so any questions?